Good evening, Bearcats. Okay, this is 2.4 complex numbers. Mrs. Zorn here with your evening instruction. We are going to do a few examples and learn by example because all of this is review. These are complex numbers. You did these in Algebra 2 last year. So I'm just going to do a few of these, which means you'll have a few less problems for classwork, and hopefully this will help resolve any questions you might have. We're going to start on page 167, and we're starting with problem number 20. First problem is 3 plus 2i, and we're subtracting from that 6 plus 13i. One of the things I want to remind you is that the form for complex numbers is a plus bi, and that is the official form. So a would be your constant or your non-imaginary number, and then bi would be the imaginary part, b would be the coefficient in front of the imaginary value. All right, so remember we want to distribute a negative, so we have 3 plus 2i. We would have minus 6 and then minus 13i. We would combine like terms. Let's see, we have a 3 and a negative 6, so that would give us a negative 3. We have a 2i and a negative 13i. That'd be a negative 11i. And I believe that your answer would be negative 3 minus 11i, and that is just combining like terms and operations of complex numbers. The next problem we're going to do is number 22, and the problem there is 8 plus the square root of negative 18 and minus parentheses 4 plus 3 roots of 2i. All right, we've got several things going on here. First, we need to simplify the square root of negative 18. I'm going to go over here to the side, depending on the teacher you had last year. But if you had me for Algebra 2, I know we did it this way. I also know that if you did it early in the year, Ms. Schoen showed you this. So I'm going to take the negative first and pull it on the outside. So we know that the negative will come out. So we'll have an I that'll represent the negative. Oh, and you know what? This I right here really is not under the radical. I'm going to erase that. And the book lets you put that at the end. I'm not real fond of that method, so I'm going to put that right here in the front. So I'm going to write as 3i square roots of 2. We can move it when we get ready to write the proper form, but that just assures us it is not underneath the radical. Alright, so I'm going to make this I square roots of 18, and then I'm going to simplify the square root of 18. I use prime factors, and I do this little upside down division because it works for all your roots. So I'm going to go over here and use prime numbers only. So I would divide by 2, and that would be 9. I would divide by 3, and that would be 3. Alright, because I'm talking about a square root, I need a pair before that can come out of the house. So 3 will come out of the house. 2 has no friends, 2 will stay home. So this will become 3i square roots of 2. So all of this will become 3i square roots of 2. So we'll have 8 plus 3i square roots of 2. And then we have minus parentheses 4 plus 3i square roots of 2. Distribute the negative, and we have 8 plus 3i square roots of 2 minus 4 minus 3i square roots of 2. Well, we have a negative 3i square roots of 2 and a positive 3i square roots of 2. Those will cancel. We have 8 minus 4, so 4 will be your final answer on that. All right, let's move on to another section. All right, we're going to keep moving on. We're going to move on in that same section, but we're going to move to problem number 33. Problem 33 asks us to perform the operation and write in standard form again. And here is the problem that we have. We have 4 plus 5i, and on the outside of that we have a square. Now, if you haven't gone over this year, I bet you have, but if you haven't, we need to review the shortcut when we have a binomial squared. A binomial means we have two terms and a square on the outside. There's a shortcut This is so we don't have to go over and go 4 plus 5i times 4 plus 5i and FOIL. You can do all that, but boy, it takes a lot more time and there's a lot more places to make mistakes. So the shortcut is we're going to take the first term, which is 4, and we're going to square it. So 4 squared would be 16. We're going to multiply everything together. 2 times 5i times 4. Well, 2 times 4 would be 8, and 8 times 5i would be positive 40i. And then we're going to take the last term and we're going to square it. Now that gets a little trickier with complex numbers. 5 squared would be 25, and I squared would be I squared. And hopefully you remember that I squared is equal to a negative 1. So this is like saying 25 times negative 1, which would make it minus 25. So we'd have 16 plus 40i minus 25. And then we would want to combine like terms. So we have a 16 and a minus 25. Remember, we're trying to get to that a plus bi is our proper form. Go Bearcats. All right, when we do that, 16 minus 25 is going to give us a negative 9, and then plus 40i. And that would be the answer in simplified form to this problem. Okay, we're going to move on one more time to another section. We'll do problem 49. This is just giving you a sample and a review of all the things that you're supposed to already know. This problem is also write the quotient in standard form. So again, we want to try to write it in a plus bi form. And 49 is 3 plus I over 3 minus I. Okay, you may remember when we have a fraction like this that we don't like to have complex or imaginary solutions in our denominator. So we're going to get rid of our denominator. We're going to get rid of the imaginary number in our denominator by multiplying by its conjugate. It's complex conjugate in this case. So we're going to multiply by 3 plus I. And remember, in math, we like to be fair and equal. So if we do something in the denominator, we most often do it in the numerator as well. So I'll multiply by 3 plus I here as well. We're rationalizing our denominator, so to speak, or clearing out our imaginary number in the bottom. All right, here we go. So let's go ahead and do the bottom first, the denominator first, because that's the whole point of us doing this. If we go through and do this, this is not a binomial squared in the denominator. These are complex conjugates, so they are the middle is going to cancel out, but we're going to review that. So we would do 3 times 3, which is 9. And then we would have 3 times I is a positive 3i, but then right after that we would have 3 negative I times 3 would be a negative 3i, and those would cancel out. And last, we would have a negative I times a positive I, which is a negative I squared. But remember what I said, I squared is the same as negative 1, so it'd be like minus a negative 1 or plus a positive, giving us a denominator of 10. That's important. Now, in this particular problem, this is like a binomial squared. So it may be actually easier for us to go ahead and write it that way, 3 plus I squared. Then we can use our little shortcut to simplify. So you would take the first term, 3, and square it. That would be 9. You'd multiply everything together. 3 times 2 is 6 times I would be positive 6I. And then you'd take I and square it, which would be positive I squared, which we now know is really negative 1. So we have a 9 and a negative 1, which is 8. So we have 8 plus 6i over 10. Now, I'm going to have you break this into 2 separate fractions so you can simplify each fraction. There will be several ways that you could write this, but we're going to just break it into 2 fractions. We're going to make this 8 over 10 plus 6i over 10. We're going to simplify this fraction. Both are divisible by 2. That would make it 4/5. 6/10 is also divisible by 2, which makes it 3/5 I, and that lets us be in a plus bi form. Go Bearcats. All right, let's move on. We're going to go on to 55. I think I have about 3 more problems to go over with you, and that should get you in good shape for your classwork. So we're going to go to problem 55. All All right, problem 55, we get a little bit more complicated. Again, we're writing the result in standard form. Our problem is 2 over 1, plus I, and then we're going to subtract. That's one thing that makes it complicated whenever we're subtracting. Also, we notice we have a fraction, and we're subtracting 3 over 1 minus I. All right, this gets a little bit complicated. To be able to subtract fractions, they have to have a common denominator. So we would need to multiply the this side by 1 plus I, and we would do that at the top as well. We would need to multiply this side. I'm going to move that 55 over just a little. This side by 1 minus I, and do that at the top as well. We do that for a couple reasons. One, I know you're thinking, oh, she did that to cancel out your imaginary number in the denominator. I really didn't. That just kind of worked out that way. I did it first and foremost so that we would have common denominators. All right, so right now I'm going to write this as one denominator, and then we'll simplify it. So my denominator now is the same for both. It's 1 minus I times 1 plus I. And we are going to simplify that. At the top, let's go really slow. We're going to distribute the 2, and we get 2. And we're distribute the 2, and we get minus 2I. And then here you can distribute the 3, and then distribute the negative, or you can pick up this negative with the 3, which is what I'd like to do. So negative 3 times 1 is negative 3, and negative 3 times I is negative 3I. Let's move on and simplify. Let's look at the top. At the top, we have a 2 and a negative 3, that's negative 1. We have a negative 2I and a negative 3I, so that's negative 5I. And in the denominator, we have our complex conjugates again, so we're going to get 1 times 1 is 1, and we know the middle will cancel, and we'll have negative I times I, which is negative I squared. Remember, that is the same as negative 1. We have a minus a negative. That will be plus a positive. So we end up with negative 1 minus 5I over 2. Now, we still want to write that in the right form, so let's separate it into two different parts. So we have negative 1 over 2 minus 5 over 2I. And I believe that we can leave our problem that way. This is our A plus BI form. So this would be our A, this would be our B, and of course this would be our I. So that would be your final answer. What would I say? Go Bearcats. All right, 2 more problems and we're done with this unit, and then I'm going to go ahead and do the next one on a separate video that you can watch as well that will help you with what your assignment on Monday night is. So you can go ahead and watch it, and that will help you get through that assignment. What I will try to do in the future is have the instruction up the night before, and then you'll work on work in class during the day so I can answer questions that you might be confused about. All right, we're going to move on to problem 59. Okay, problem 59. We're on page 168, and problem 59 is the square root of a negative 6, and we're going to multiply times the square root of a negative 2. The first thing we want to do, you cannot multiply the negative and the 2 and get a positive number. You need to pull out an I for these negative values. So we're going to say I square roots of 6 times I square roots of 2. That's really, really important. So I times I would be I squared. And square root of 6 times the square root of 2 is the square root of 12. So you can leave it like that for now. We're going to simplify some things. Remember, I squared is the same as negative 1. So I'm going to put a negative 1. We have negative 1 times the square root of 12. Now I'm going to simplify the square root of 12 as we did earlier. I used a little upside down prime factorization. So we're going to divide by 2 and get 6, divide by 2 and get 3. We have a pair of 2, so 2 can come out. 3, of course, doesn't have a friend. It'll stay home. So 2 will be out, and we have a negative 1 times 2 on the outside of the house. So we have negative 2 square roots of 3 as our final answer. Hopefully that's a good review for you. All right, last problem for this instructional time, number 67. All right, problem 67 is 4x squared plus 16x plus 17 equals 0. I'm going to get this set up for you, and we're going to solve this quadratic equation. And we're going to find that we end up with a complex number. So we can't divide anything through. We don't have any common factors. Those are always the things you want to start looking for. So, and it looks like it's a little complicated. So we're going to go ahead and use the quadratic formula. There's our A would be 4, our B will be positive 16, and our C will be 17. And hopefully you remember the quadratic formula is negative B, or x equals, I should say, negative b plus or minus the square root of b squared, I always put that in parentheses, minus 4 times a times c all over 2 times a. So let's go ahead and set this up. So that would be negative 16 plus or minus the square root of, parentheses, 16 squared, minus 4 times a, which is 4, times c, which is 17, all over 2 times a. I like to take this in steps, and I really want you to think about your steps using the quadratic. We would have negative 16 plus or minus the square root of a number. That number underneath the house is called the discriminant. Hopefully you've talked about that again this year, but that is the discriminant, and it determines the number and type of solutions that we have, all over 2 times 4, which is 8. So hold on just a second, and I'll figure out what that number is underneath, and we will go on from there. Okay, 16 squared is 256. 4 times 4 times 17 is 272. So we have 256 minus 272 that will be under the house. That actually is a negative 16. All right, negative 16. It's a negative number, so we're going to have two complex imaginary numbers. That's important for you to know. That's what that part of the discriminant, that's what the discriminant tells us when it's negative. We're going to take an I out for the negative, so I'm going to rewrite this as negative 16 plus or minus I, and then square roots of 16 over 8. We're going to simplify a little bit further. We have negative 16 plus or minus 4. The square root of 16 is 4, so 4I over 8. And since 8 is shared denominator, we're going to break it into two different fractions. We have negative 16 eighths plus or minus 4I over 8, and we will finally simplify. Negative 16 over 8 is negative 2. 4 over 8 is 1/2, so plus or minus 1/2 I. Now that is really two answers, because that gives you positive, so that gives you negative 2 plus 1/2 I and negative 2 minus 1/2 I. But you may leave your answer in that form, and that would be your final answer. Okay, that's a review of complex numbers. Hopefully that got you through several of your questions. I am right across the hall this week. If you need any help, please come over and ask me, and go Bearcats. Have a great evening.